Welcome back. This is Professor Needing, and I'm doing another Math 168 video for Desmos, and today we're going to find the critical z-score and the endpoints. So in retrospect, that's in a reverse of what we did last time. Last time, given a pair of z's or a pair of endpoints, we calculated the area under the curve. We did that area to the left, we did that area to the right, we did that area in between. What we want to do now is, given some area, or some probability, because remember, a p-score is a probability or an area under a curve. Tell me the designated points that would go with that. Remember, symmetry is always part of that. So in other words, for instance, if I knew I had 68.2 area, could I come up with a cut score of -1 and +1 for my z standard deviations? Well, let's go see what happens when we try that. I've got some notes off here to the side. Don't pay attention to those right now. We'll deal with them. So how can I do that? So remember that, and remember your GUI functions here. Your functions over here. If we do your distribution, if we do your normal distribution, remember that a normal distribution of 0, 1 gives me a normal curve distributed 2 standard deviations to the left and 2 standard deviations to the right. And what I'm looking at is to say that, okay, how do I know what the numbers are that correlate themselves with these two green values, which would be 68.2%? Okay, so if I go back and I say, okay, I want to actually undo this. So I'm going to go here, and instead of using the function of normal distribution, I'm going to use the function of inverse CDF. Now, it's kind of strange. Inside inverse CDF, I have to tell it what I actually want to distribute, okay? And I actually have to tell it to distribute. If I just type in, for instance, 0, 1, and I tell it something after that, it's really not going to do a whole lot for me. I have to tell it what to distribute. I have to tell it I want to distribute this normal CDF right here. So actually what I want to do is undistribute the normal distribution. Now, I'm not quite done yet. Notice that what you see is that you see a 0, 1. So that's the distribution I'm utilizing. I have to hit another comma, and then I have to tell it area to the left. It's always the area to the left. What it's looking for here is the endpoint that will happen on a normal distribution of 0, 1 if you want this particular area at the end. So we have to put some kind of area right here. And the area has to be as a decimal, and it has to be between 0 and 1. Okay, well, we have to go back and rethink our situation. So our situation over here was we wanted 68% or 34.1% area on the left side is what we want. Well, what we're looking for is a score right here that will contain the rest of the area. Well, that's 34.1 taken away from 50. And I'm going to go over and type that. So really what we're talking about here is we're talking about taking 50% or 0.5, because that's the left-hand side of the curve, and we're talking about removing from that curve 34.1%. So we have to do a little bit of math here. 0.341%. Okay? So if we actually take those, and I think actually Desmos might actually do this for us if we did that. Oops, I did that. Sorry, I did that as a quotation. I don't want to do that as a quotation. I actually want to do that as a number. That was my fault. I quoted that. So I want to take 0.5 and I want to subtract from it. And remember, that was 0.341. So the area that really I want to look for here is 0.159. So up here, I want 0.159. It says that you should have a z-score, this is my z-score, of approximately 0.998. Well, remember back here, remember what I said that was supposed to be when we were working? It's supposed to be 1 right here. That green is supposed to be a -1. Well, if you round 0.09985 in any manner you want, you're going to get -1. So I'm going to go up here to our distribution, and I'm going to put in a -1. So right now, I have a -1. Okay, well, let's go check that other one. So remember, on the other side, it's identical, right? The 50% is over here. From the center of mu to the right is 50%. So this is still 1 minus 50% over here. But this one over here is going to be a positive value instead of a negative value. So if we go back and we take a look at this again, I said, hey, you know what? I want to redo this. And I want to take this entire formula right here, right there, and I want to redo this. Control copy. and Control V. Okay. Now I'm not looking, remember, this is area to left, though. So see, that's a significant issue. If the calculator will only calculate the area to the left-hand side, it won't calculate anything else to get the z-score or to get the inverse point, if you will, then when I'm looking at my mathematics, I have to think in terms of, okay, if I want this number right here, if I want this 1, then it's everything to the left is the area that I want. Okay, well, what I really want here is I want 50%. I want this right side 50, plus I want 34.1%. So I want 50, 84.1%. That's really what I want here. 50 plus 34.1 is 84.1. I want 84.1% or 0.841. So I go back to Desmos and I say, hey, area to the left. Area to the left is 841. Look at what happens. Positive 1. So I go up here and I make my curve positive 1. I have just made an area. Here it is right here. You can see it. 68%. And if I go over here, 68%, 68.2, I'm good enough. And if I did my rounding, I'd be okay. With endpoints of negative 9998, or how about negative 1 and positive 1? So my two z-scores are negative 1 and positive 1 that accumulate with that area. Now, another way to get that, if I don't want to take 50% plus 34.1, I know that 34.1 over here is taken away from 50. So if I think in that same manner over here, if I go over here and I do another one, 0.5, and I take away that 0.341, remember that 159 over there, that's the right side area. That's over here. That's this over here. Remember, I want everything to the left. Okay, well, I could have done 1.0, because remember, all the curve minus 0.159, and I would have got that 841 also. So you can think about that any way you like when you're doing it, but you have to always have the left area. Always the left area. We'll do a couple more here. So let me get rid of these things that I have going on here. I should just put them in a folder, but that'll take too long, and I'll just make all this go away. And we're going to remember left area. So I'm going to leave that notation right there for now. Let's do this top one. What does the endpoint z in a standard normal distribution if the area to the left of z is 0.15? Okay, first thing I'm going to do is I'm going to put up a standard normal. You know that, or type. I'm still messing it up. Sometimes when it gives me a fit like that, I just come down here and I grab the standard normal, and the first thing I do is I do the normal distribution. All right, so the normal distribution, 0, 1. It's already there for me, but I like to see that thing, so I'm going to put a 0, 1, and I'm going to put the cumulative PDF on there. So we want to have endpoints, so we don't know endpoints, but we only want the area to the left of this thing to be 0.15. We can't just simply pump in an area number up here. We can't just simply do numbers and calculate things. Because look, if I try to change that area, look what it just did to me. It completely messes me up. So what do? So we use the inverse function. So let's go here, go to functions, grab the inverse CDF. Inside the inverse CDF, we want to put in the normal distribution. I just copy it right here. If I couldn't copy it, well, then I got to either type it or I got to go grab it, one of the two. So I'm going to stick it in there. Now remember, it's comma, because we have to tell it some kind of area to put to the left-hand side. The area they want to the left-hand side is already 0.15. My z-score appears to be negative 1.03 or 1.36. I'm going to use negative 1.036. So I'm going to come up here and I'm going to put in, remember, I want the area to the left. So my maximum number is going to be negative 1.036. I would have approximately, and this is why do I do this? Why do I plug it back in here? Because remember what the problem said. I want the area to the left to be approximately 15%, 0.015. Look at the area, 0.15. I know that my critical z-score, or my endpoint, will designate 15% of the area this way. It also knows that 85% of the area is over this way to the right. Let's try a different one. I'm going to hide both of these. And I'm probably going to use these because I'll just use a little cut and paste. I'm going to leave this one up here. I'm going to get rid of this one right here, the normal CDF. So let's get a new one. It says, what is the endpoint Z if the standard normal distribution area to the right is 0.75? Okay, well, remember your first thinking. If this thing says area to the right is 0.75, we have to think 1.0 minus 0.75, which is obviously 0.25. That means area to the left is equal to 0.25. We can't put 0.75 in the calculator because it'll put 75 of the area on the left. We want 25% on the left so that we have 75 on the right. So let's go do this command right here. And we'll do just a little bit of modification inside this command because this command is going to find for us the endpoint. It's still a 0, 1, but now on the left-hand side, we need to modify to 2.5. We're telling it I want 2.5 or 25% of the values on the left-hand side. Now remember, this shading is not correct for this number. I now have to take this number and put it into my maximum. So I go to my max up here. And I got to scoot over because I got some numbers in there. And my maximum, I just lost it, is negative 0.67. We'll just go negative 0.67. Negative 0.67. Now again, why did I do that? Because remember the deal. I want 75% on the right. Well, look at what it says I have. It says I have 25% on the left. If you have 25% in purple, you have 75% in white. So this value of negative 0.67 is my critical z-score. And that's what the question was asking. What is the endpoint z? So the answer to the endpoint z, oops, I gotta always use quotations when I do this. The endpoint z equals negative 0.67. We'll do the last one. And I'm going to get rid of this stuff that's up here because we're getting a little busy here. I'm not going to get rid of this normal distribution, though, because I just got done using this thing a second ago. And I'm going to use it again, just as a template, if you will. What are the endpoints? So now there's two of them. Z in a standard normal distribution if the area between z's, I should say z's, are 0.89. Okay, so again, go back to my picture. If the area between something is 0.89, then the tails are 100% take away the area in the middle. So I'm going to go to my calculation. I'm going to go, okay, 1 minus 0.89. That means there is 11% sitting on the two tails. Well, 11% divided by 2 means that approximately I want area on two sides of 0.055. Perfect. So I'm going to go up here to this calculation. All I'm going to do is I'm going to change this calculation right here to 0.55. Because remember, it will only think in terms of left. It says that I have a critical z-score of 0.13 if I round. So let's go put that in. Let's go put in a value that says, oh, hold on a second, I messed up. It's 0.05. Let me put a 0 in there because that was way too big of a number. There we go. So I have a negative 159, or how about a negative 1.6? So let's go in here. Let's put a negative 1.6. And one more part. Think about what else do I need? I still need the opposite side. Sorry, I had to take a break there for a second. Remember, this is only one side of my critical z. Now think about what we did here. We took and we used this percentile against the left-hand side, this 0.0005. Well, don't we also need all of the middle, or we need this other value up here? Well, that other value means that there's a tail with 0.055 hanging out. So if we did 1 minus 0.055, we'd get this other number of 945. Okay, well, let's see what happens when we run this value. So we're going to take this value. Remember, undo. There's an undo here, but there's also a Control Z to redo because I just messed up. I want to take all this and I want to copy this thing. Make a new line. And I want to have a 9 in here. And I want to change that other number to a 4. So what I've just done is I've included all of the area under the curve and all of the area to the right of the curve, but I've left out a tail on the other side of 0.055. Look at it. Amazing, right? Here's the positive, or here's the negative, and here's the positive. How come they're the same? Because the curve is symmetric. So really, I could have just simply known that I can take this value and I can turn this into 1.6. Got to get rid of that negative right there. And there's my curve. So my curve that lies between the two numbers, negative 1.59 or 1.6 and positive 1.6, will contain, right here it is, approximately 89% of the area. And remember, up here, what are the 2 points that lie between 89%? I don't think it could work any easier for us. If you have any questions, feel free to email me. Enjoy Desmos.